Hello, so today we're revising a part of the water cycle, part of the spec, and today we'll be looking at the causes of flooding. So today's lesson will cover the physical, human and meteorological causes of flooding, types of flooding and how to read a synoptic chart. But don't forget that the full lesson for this topic is on the shared area. So the first thing to make sure that you remember is what is flooding, and that the definition of flooding is as follows, as it says on the slide. So flooding occurs when a river's discharge exceeds the capacity of its channel to carry that discharge and the river overflows its banks. And there are various causes of flooding, obviously climatic, in other words meteorological, human, where people have exacerbated the risk, and physical, caused by features of the land. So these images show a number of floods and possible reasons for floods, and we're going to examine some of these reasons in more detail. So what I'd like you to do now is make 3 headings in your notes on the causes of flooding: physical, meteorological, this means to do with weather events, and human. And then what you should do once you have made this table is you should pause the video here and complete this table before continuing this presentation. And welcome back, and hopefully you've put some of these factors into your physical or meteorological causes of flooding, and we'll look at these in more detail. So you can have a look at these reasons on here to do with the shape of the land and the climate, what the weather has been like in the previous days before a flood, whether an area is prone to snowmelt, what the underlying rock is, and whether the rainfall is frontal rainfall or whether it is a flash storm event, various reasons. And here you can also see some human causes of flooding. You may have many more in your table, and I have detailed quite a few different causes of flooding here in my completed table. And hopefully some of those of you who are aiming for A and A star, which should be all of you, will have noted that climate change will quite obviously exacerbate the risk of flooding and the frequency of flooding due to increased storminess and of the atmosphere generally. So we look at different environments, so you can see that certain environments are more at risk of flooding, and that would be places that are low-lying anyway. So Bangladesh, for example, is a low-lying nation, and many people live on the coast. So Bangladesh is a country that is very prone to flooding. Other areas are prone to flooding or more at risk from flooding because they're urbanised. So being an urbanised area can cause more flooding, in that impermeable surfaces of concrete and pavements can lead to more surface runoff, which leads to more flooding, but they're also more at risk from flooding because more people are exposed to the river's flood. Small river basins are more likely to flood, and areas where the housing quality is low, obviously this does not increase the likelihood of flooding, but increases the risk from flooding. So make sure that you use this next slide to add some more details to your notes, and you could pause the video again here to ensure that you have these 3 definitions in your notes: groundwater flooding, surface water flooding, and flash flooding. And this diagram here shows maybe a flood basin, a river basin with a number of potential flood factors involved here. So we have this river here is dammed in its upper course. You can see the dam up here. So this has the potential to increase flooding above the dam, and perhaps if the dam failed due to too much water above the dam, there will obviously be an increased risk of flooding below the dam. It's possible that this dam was put into this river basin to reduce the risk of flooding for these areas further downstream. We have the size of the catchment area, and if we have steep slopes over here like this, you would expect a river perhaps to flood more quickly because water will be returned to the basin more quickly than in a river which has a larger, flatter shaped basin. There aren't soil types listed on here, but impermeable soil types like clay are more likely to lead to flooding because the water cannot infiltrate the ground and percolate down into the water table, What else have we got here? We've got land use. So some of the land use here, we have farming. So perhaps if a farmer irrigates, that would reduce the risk of flood use because he's using water, he or she would be using water from the river. If animals are grazing the floodplain, they can compact the earth and cause an increased amount of surface runoff. Ploughing can increase the risk of flooding. Over here we have another form of land use, urbanisation. So as mentioned earlier, if an area is urbanised, there is more chance of flooding because there are more impermeable surfaces, but in addition to that, there are more people at risk of flooding. Floodplain structures, if anything is built on the floodplain, it can lead to an increase in flooding. We have vegetation up here. The more vegetation there is in a catchment area, the greater infiltration there is, and therefore flooding is reduced. Obviously, the amount of rainfall isn't reduced from an event. However, the lag time in that the time it takes the water to reach the river basin is reduced, so the flood will be less flashy in its shape. And we have historic rainfall here, so if an event is a one-off, a river is more likely to cope, whereas if there has been a frequent number of rainfall events in recent times, then a river is more likely to flood, as the water table will be higher. Maybe the soil is full to the top, so we have a lot of surface runoff because there is no more capacity for the soil to absorb any of the water. And we have some types of flooding here, which hopefully you remember from your lessons. So we have groundwater flooding, flash flooding, yokel and surface water flooding. So you should pause the video at this time to ensure that you can match these key terms to the correct meaning. So these are the definitions in the correct place, and hopefully you had no problem in putting these key terms with the correct definition. The only one that you may not have heard of is a yokel, and this is maybe a Scandinavian word where a lake that is formed from glacial meltwater, which is dammed, fails and the water floods a valley below. So you can see here this graphic from the Millennium Ecosystem Assessment shows us the frequency of flooding over decades going back to the 1950s. And as you can see, there are two things to take from this graphic. If you were given this in the exam conditions, the examiner may ask you to comment on the data shown in this figure, and you hopefully would realise that there are more events occurring in Asia. That would be one factor, and fewer events occurring in Oceania. However, the number of events in all regions has increased, although the biggest increase has possibly been in Africa and Asia than in other areas of the world. So how do we calculate the flood risk for an area? So we can see that an area has more flood events occurring, but how do people actually calculate the flood risk for an area? So the risk of a flood is calculated from its frequency, how often a flood occurs, the magnitude of the flood, i.e. how big the flood is, the number and density of people living in the affected area. Obviously, a river may flood in an area where there are very few people, although such as the Amazon basin, although there are very few floods there are very few rivers in the world where people are not living in close proximity to them. The amount of flood protection, so obviously the more urbanised and built up an area is, the more flood protection is likely to be. The level of economic development also indicates how at risk an area is from flooding. This is not how many floods occur, but it's to do with what the risk of a flood occurring is. So the risk to the people. If an area is a multi-hazard zone, for example, the Philippines, if a flood occurs in an area which is prone to storm and hurricane events, or which is prone to earthquakes or other tectonic events, clearly an area is going to be more at risk from another event occurring. And the system of government in a country can affect people's risk from flooding in that some governments are more prepared, some governments are more able to combat the effects of flooding, and some governments are more corrupt, so respond in different ways to flooding events. When we calculate the flood frequency, we use this formula. There are a number of other formulas, but this is the one that you were expected to know about on the Edexcel spec. And this is T, the recurrence interval, which is how often a flood of a certain magnitude is likely to occur. And you calculate this by looking at N, the number of years of observation, plus 1, divided by the rank order. And you would rank the order of a flood based on floods in a certain area, and the largest flood that you had in your historical data will be ranked 1, and you would rank all floods in the area from 1 to however many floods there had been, and this is based on a river's discharge. So once you put your numbers into this formula, if you get a 1 in 75 chance of a flood occurring, that would be a significant risk, and then we have a moderate risk, 1 in 75, but below 1 in 200, and a low risk of 1 in 200. So in other words, if the chance of flooding is 200 to 1, or a 1 flood chance in 200, there is less chance of that flood occurring. So the chance of a very large flood occurring is smaller than the chance of a smaller flood occurring. Therefore, the recurrence interval will be lower. So when people are working out a flood risk for an area, they use the recurrence interval, and they take on board the fact that floods of a very large magnitude don't happen very often, but they're more damaging when they do. And in addition to that, smaller magnitude floods are more frequent. However, a river that's constantly flooding is potentially as risk-making to the people living nearby as one which floods infrequently but of a large amount. Of course, many rivers flood with a small magnitude frequently, and of a large magnitude less frequently. And larger floods usually occur because there's been periods of heavy or prolonged rainfall, which has been the case in the early parts of this year in the United Kingdom. So even in areas where there aren't very frequent floods, large floods can still happen at certain times of the year because there could be monsoon rain or snowmelt. And knowing all these factors allows planners to zone the floodplain and to plan the land use in the area. So we have these two graphics in the middle here which show the flood return period. So this shows that the return period is the same as the recurrence interval. So the larger the recurrence interval, sorry, just let my dog out the room. The larger the recurrence interval, the flood return period, the larger the flood. So a flood return period of 500 years means a flood of that size may not return for 500 years. And that flood clearly is going to be bigger than a flood which returns every 25 years. And you can see on this diagram here, we've got the extent of the impact upon a river of certain flood events. So obviously this river is it has a lot of discharge. It might come up to the 100-year floodplain, which will obviously be a lot higher than the lower floodplains here. So you could have a go at this exam question here, which shows a figure with flood zones on it. So the typical questions might be for this: define the flood recurrence interval for 2 marks, explain the relationship between the flood recurrence interval and the severity of flooding, and finally, suggest how flood recurrence could influence land use planning and building regulations. So what you should do at this point is pause the video and try and answer these questions to make sure that you understand what's going on. And here is the answers that I wrote for this question. So have a check of your answers here compared with my answers and see if you agree with if what you've written is similar to what I've written, and whether you feel that you've done well on this. You could pause this again and have a look. So we could have a look at obviously the number of deaths from natural disasters. You can use the website Our World in Data to find out anything. It's have great graphics of various things around the world data-wise, and you can look at the natural disasters section. And as you can see here, that the number of deaths from natural disasters obviously was biggest in the 1920s, of which droughts killed more people. This was actually a period in America known as where lots of American planes were known as the Dust Bowl, and it also corresponded with the Great Depression. And you can see, hopefully, that over time, the greatest sort of risk from natural disasters for people now is earthquakes, actually, and flooding here. We have fewer people dying from flooding. Most people died from flooding in the 1930s and the 1950s. However, as we've seen from the previous slide, the number of flood events is actually increasing. So one thing that the examiner is very keen for you to understand is the link between storm events and flooding in river basins. So you can see here a typical satellite image of the clouds from above. This would be the northern coast of Scotland here, and this would be the typical swirly pattern of a storm over the United Kingdom. And here you would see the eye of the storm passing from west to east over the United Kingdom. And this is the nomenclature used by the Met Office to name storms for this year. So we can see that we've had these A, B and C and D already this year. So you can see that we also had Jorge on the 27th of February. So these storms are named alternating between girl and boy every year. And the names of storms are given to the Met Office and the Irish Meteorological Office and the Dutch Meteorological Office, and the members of the public can suggest names so that names of people in all areas are representative, and then these three groups of meteorological people decide which name to call a certain storm. So we don't use Q, U, X, Y or Z because this is the system used by the United States for hurricanes, so we stuck with the same system. If a hurricane comes and causes a lesser storm event in the United Kingdom, then what happens is the name of the hurricane is used in place of the name of a storm. So these are smaller magnitude events, although very impactful in the United Kingdom. So you can have a look at the Met Office if you want to see more about these storms. The other thing you have to be able to do is to interpret a synoptic chart, and the synoptic means putting many things together. So a synoptic chart puts information from weather areas or stations all together onto one chart and allows meteorologists to predict what the weather is going to be like. So you can go onto the shared area and look at the Met Office, which has a read a synoptic chart link, and you could Google that, and the Met Office taught you through how to read a synoptic chart. But also you can see on here the symbols that are used on weather charts. So we have symbols for the type of conditions, symbols for the amount of cloud cover, and this is done in octas, which just means eighths. And we have one octa here, so that, clear sky with nothing in would be a beautiful day with no clouds, and obviously 8 octas would be completely covered in cloud. And then we have wind speed, we have direction of the wind, obviously the way the stick point shows the direction of the wind, where the wind is coming from, and also the number of little feathers on the stick show you the actual wind speed. So if there's just a stick, it's very calm wind speed, or not completely calm, but 1 to 2 knots. And then as soon as you get beyond 20 knots, we get the number of feathers keeps adding until you get up to 50 knots, and that would be exceedingly windy. So there is a synoptic chart here for the southern part of the United Kingdom. So we have Wales here, we have London around here. So we see the little synoptic symbols here. These numbers are the temperature. The little sticks show where the wind is coming from. The feathers show the wind speed. And the symbol within the little thing, which is hard to see, tells you what the weather conditions are like. And we can see that here we have black completely filled in. So that would be 8 octas, i.e. completely cloudy. Wind from the southeast, quite windy, and the temperature, so it shows you. And you can have a look here on a little synoptic symbol, and this is giving you the temperature, the current weather, which means drizzly, the dew point, i.e. the temperature at which dew will form in the air, the weather since the last measurement, so what it was like before, how much cloud there is, the pressure, the wind direction, and the wind speed. And again, you could pause the video here and have a look and try and interpret the weather on this symbol. So hopefully this is what you interpreted from the synoptic symbol, and you can check whether you got the answer right, and hopefully you have. So you can go on the college portal and use these links to look at, again, a different Met Office link and a BBC Bite-Size link that show you more about synoptic charts. But what you can see here, the red lines here show a warm front with the little curved blobs on the front, and the blobs show the direction of travel, so it's going this way and this bit is going this way. These blue lines show cold fronts, and the spiky little triangles show a cold front and the direction of travel. The little things are on the side of the direction of travel. We have black lines on here, which are isobars, lines which join together places of equal pressure. And you can see here that the actual pressure is given here, 1004 millibars. And when you have a circle like this, that shows you areas of same pressure. So at the centre of that would be a centre of a low pressure system, which basically means a storm. High pressure is when air is rising, so this would tend to lead to clear and cloudless days with not much wind. So here you can have a look at this chart here and try and interpret what the symbols and lines mean. So you could pause the video at this point and complete these boxes to show that you understand what's going on.